Last time we ended up with the top part of the hull with the coverlet glued into it. I can securely attach the roll cage using 6 screws. In this video we will be gluing the two halves of the hull together. I decided that the easiest way to do it would be to start with the flat chamber wall. I cut the flat chamber wall out of a carbon fiber sheet and I will glue it into the top part of the hull. By the way, I have already uploaded all the files which I am using to build this hull on my CG Trader page for free. So if you wish to build this hull for yourself, you can. Just use the link in the description and follow my steps in the videos. To put the flat chamber wall into the correct position, there is a small channel in the coverlet. After some small sanding, the flat chamber wall will sit in the hull perfectly. I also need to make sure that I will glue the flat chamber wall into the hull 90 degrees straight up, and this is why I have built this small jig and I can securely clamp the flat chamber wall to it. Now I can check that everything sits properly and I can start applying the epoxy. This is quite a critical step because I don't want any leaks in the boat, so I better apply a lot of glue to make sure that no water comes through from the flat chamber to the hull. After securing everything in place and using the clamps, I thought I did quite a good job with the glue. But I still wasn't sure if this part wouldn't break or leak somewhere, which would be terrible because there is bad access to this part. So I decided to apply some fiberglass tape around the flat chamber wall and also around the coverlet. This step might not be necessary and I could have saved some weight, but I better make sure. After this step, it was finally time to glue the halves together. And again, the most important thing right here is to make sure the flat chamber won't leak. Because especially after joining the halves together, there is no way to access the front part of the flat chamber wall. It seemed obvious to me that I should also apply glue on the hull itself, but this was probably a mistake, because the glue just started flowing down and created unnecessary weight instead of gluing the halves. So the better way would be probably just to glue the flat chamber for now and use paper tape to align the halves together. Then it is really easy to work on the hull from the outer side. The next step for me was to reinforce the flat chamber joint with a fiberglass tape, as I did before. And after this step, I finally became quite confident about this part of the construction. Now that the flat chamber wall holds the halves together itself, it is a good time to start working on the outer side and join the halves together firmly. Right here I made a big mistake by not sanding the hull before applying the fiberglass on the top. The problem was that the two halves of the hull were not aligned properly, probably because of some deformation, and this little gap created problems with the fiberglassing, creating bubbles. So then I had to sand this part off and start again. I won't show you this on the video. But anyway, I used this procedure around the whole hull and this created a nice joint everywhere. The obvious disadvantage of this method is that you don't get nice surface on the top. This can really be a problem if you care about the visual side of things. But the surface of my hull is not shiny anyway, so I don't mind doing this. The main thing for me is functionality and weight. After finishing this process, my next step was to cut the flat chamber hole. The holes in the flat chamber need to be cut in 3 places in order to work properly and supply the water into it. The first hole needs to be in the bottom part of the stern. Another one needs to be in the top part of the stern, because when the boat is flipped, the first hole is above waterline. And the last one will be in the front, but I need to cut that one later. And now let's go for a little test. Okay, enough. And this is 0 water. Perfect. This is self-righting. When I put the electronic inside, it should hopefully work the opposite way. So let's see how is the weight. 300, 380 grams. I'm happy with that, I can take that. I think the hull I made before had 400 grams and it had no flat chamber. So this is quite a good result for me. I think I could make it 50 grams lighter if I didn't make some mistakes, like not sanding this before applying fiberglass on it, or putting too much glue here and around the cover. I think 50 grams could be saved, but not much more, using just wet layup without vacuum or so. So this is good. And in the next part we will finally install the pump. And then we are getting really close to make this boat running. Yes, actually one more thing. I think I won't give it any paint because I like to see the carbon fiber, even though it is not perfect surface. Let me know what you think. If you think that I should make it yellow or so, or put flames on it. Well, I I will not put flames on it, because that's for my another boat, flames. So thanks for watching, see you in the next one.